Okay. Oh. So let's take a look here at this probability stuff that we're gonna do. Okay. Oops, that's not the right thing. Thank you. Well. Okay. So probability is what we're looking at today. Oh, in here, Ella, I'll get you a paper too. Okay. So how do you find the probability of something happening? What do you need to know? Well, what do you need to know? How do you find a probability of something happening? What kind of information do you need to know?
We're trying to find the probability of.
Okay. That's true. So, for example, if we're talking about a coin, for example, all right, and a probability with a coin, okay? Let's say we want to know the probability of if you flip a coin and you get heads, okay, right? What is the probability of getting heads when you flip a coin?
50-50.
Okay, the probability is not 50-50. Those are the odds, actually, when you say 50-50. What's the probability? 50%, or as a fraction,
1 over 2.
1/2 or 1 over 2. Okay.
There is a very, 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 very slight chance
Of
if I make a cycle.
standing up.
That's true.
Very small.
Yeah.
You're right. You're right. That's true.
0, 0,
That's
0.
true. So we'll just say for the sake of the argument, there's only 2 possible outcomes. Okay. And so what did we need to know for the coin? We have to know the total number of possible outcomes. Okay. So for probability, it's equal to the number of favorable outcomes over the total, I'm going to abbreviate total as TTL, total number, and again, pound sign for number, total number of outcomes. Okay? So for a coin, there's really 2 outcomes. Yes, Tyler, you're right. There could be a third if it lands exactly, on its edge kind of thing. But as far as, for the most part, it's going to be 2 outcomes, heads or tails, right? And then if we're looking to land on heads or to, get that result, then we have 1 possible favorable outcome. 1 out of 2 there. Okay. Another way you can say it is what you want over the total possibilities. Okay? When you said 50-50 for the odds, when you hear odds are the number of favorable outcomes over the number of unfavorable outcomes. 50-50, 1-to-1 kind of thing. So the odds of getting heads would be 1-to-1. 1 favorable outcome, flipping and getting a head, right? And then 1 unfavorable outcome, flipping the coin, getting tails, kind of thing. So that's the odds are different. And we don't really talk too much about odds. We normally just deal with probability. Okay? So let's go through a few of these here together, right? So number 1, a number is chosen at random. And that's another important point too, right? A coin, when you flip it, ideally, the results are supposed to be random. Now, there are people that claim that they can flip coins and, kind of like force results and stuff like that. But ideally, when you're flipping a coin, you have no idea what the result's supposed to be. It's supposed to have an equal chance kind of thing. Okay, same thing here. A number is chosen at random.
It's more commonly tails.
Is it?
Not in my career.
I don't know. Everyone's got their
We should
own
debate
beliefs
it.
on
We
it.
should debate it.
Well, we can maybe do an experiment later, but not right now, okay?
Yeah.
So a number is chosen at random from 1 to 10, okay? Find the probability of selecting a 4 or smaller, okay? So Number is chosen at random from 1 to 10. Find the probability of selecting a 4 or smaller. So what's the total number of outcomes possible in this scenario?
4. Right, 10.
10 actually, yeah.
How many possible results could you have by doing this action of drawing a number at random? There are 10 possible results. You could pull out a 1, a 2, a 3, a 4, 5, 6, 7, 8, 9, or 10. That's 10 total results.
Wait, this is actually something we're gonna be doing?
Yeah. Is this too easy? Too hard?
Oh no, this is a good skill level.
A good skill level?
You said
That was a very tactful way to say it. Okay,
Yeah,
so,
it can be tactical, though.
hey, how many favorable outcomes are there?
4 small.
4, right? Because you could pull out 4, right? A 3, so you could pull out a 4, a 3, a 2, or a 1. So there's 4 favorable outcomes there out of the total of 10. Okay? Now, one other thing we could do here, right? Because it's 4 out of 10, what can we do with that fraction? Simplify it. Is it necessary? Not necessarily,
Do we have
but let's go ahead and do it just because we can. What can we divide 4 and 10 by?
2 and 5?
2, so it makes 2 fifths. Okay? So this is fine, but this is okay too. Okay? Let's try number 2. A number is chosen at random from 1 to 50. Okay, so now how many possible outcomes are available here?
50.
50, right? You got it. Find the probability of not selecting odd or prime. Ooh, okay. So how many not odd numbers are there? 25? I'd expect that to be the case, yes. Yes, 25. But then or prime as well.
What's the prime number again?
Yeah, what's a prime number?
You can only multiply it by 1 in itself.
It can only be divided by itself in 1. That's a prime number.
4. Any even number can be divided by 2.
Except for, so every even number, you're right, is divisible by 2. And so every even number is not prime except for the number 2. 2 is prime because it's divisible by itself, 2 and 1, okay? So we basically have 25 even numbers. All of them are divisible by 2, okay? So that's even, but then we also want it, we have to exclude the 2 because 2 is prime. So how many total numbers do we have then?
25.
24.
Wait, why 24?
Because the number 2 is prime. And we want to not select odd or prime numbers there.
What is your prime number again?
Prime number is a number that is divisible by itself and 1. And 1. Okay?
My
So
bad.
2 is prime. Okay? Is 1 prime, by the way?
No.
No, because it does, I mean, yes, it's only divisible by itself, but itself is 1, so it kind of doesn't, it has to kind of match both of the rules, really.
Black hole.
Separately. Yeah, it kind of doesn't quite work.
How about 0?
Right. Okay, let's take a look at number 3. Number 3, a number is chosen at random from 1 to 50. Find the probability of selecting numbers with 1 in the tens place. So again, we're choosing at random 1 to 50. Okay, at random 1 to 50. How many total outcomes, Alex, are possible here?
It would be 50.
Out of
And
50?
I guess on the above number would be maybe.
How many numbers will have 1 in the tens place?
10.
Well, let's think about it. So give me an
Oh
example.
no, 5. Because this.
Give me an example of a number with 1 in the tens place.
You have 1. You have
1 has a 1 in the ones place.
11.
10.
10,
That's really. Well, there's 11.
11.
There's 21.
21 has a 1 in the ones place.
So
2
it's
in the
only-
10 place.
It's only 11.
10 and 11.
That's 2.
Between 0, 1, and 50.
That's just 2.
12, 13, 14, 15, 16,
Oh,
17,
my bad.
18, 19. How many are there?
10.
10.
I said 10 the first time. But I
You
didn't
were,
think
but you
that
were wrong.
much.
You're right for the wrong reason, though.
Yes.
So that's why I kept pushing you. Okay. So this one then simplifies
These are
to
like mind games.
1/5. It is.
But it's very simple.
Okay. Well, I hope you feel that way. Yeah. Okay. And this one would be 12 25ths if you want to simplify it there. Of course, your calculator can simplify these fractions. Just hit math, enter, enter. Okay. Kind of thing. Okay. Let's do. Let's go ahead and do 4 and 5 here as well. Okay. Number 4. A number is chosen at random from 1 to 50. Okay. So again, our total number of outcomes here, Tyler C. We're choosing a number at random from 1 to 50, so our denominator is going to be 50 again. Find the probability of selecting numbers with a last digit of 8. 10 of them? Okay, so give me an example. You said 5. Give me an example of one with a last digit of 8. 8? 18. 28. 38. 48. There's 5 of them. That's right. Or 1/10 that you simplify there. Okay? All right, got them. Number 5. A number is chosen at random from 1 to 25. Okay, so Catherine, what's going to be our denominator here? 25. You got it, Catherine. Find the probability of not selecting a composite number. Now, what's a composite number?
A number that's too positive.
Okay, you do that.
Yes. Yeah. Okay. What's a composite number? Well, it's the opposite of a prime number. That's divisible by more than just itself in 1. So, for example, what's an example of a composite number? 6. Divisible by 2 and 3. 25. Yeah. Okay, all sorts of numbers here. So we have to think about a not composite number. So if it's not composite, that means it is what? Prime. So what are all the prime numbers between 1 and 25? Well, let's go through them here. Is 1 prime?
No.
Nope. How about 2?
Yes.
2 is 3?
No. 4.
3 is prime.
Wait, 3 is prime?
Yeah, it's only divisible by itself in 1. Okay?
5 is?
So 2, 3, not 4, 5, 6,
No.
7.
Yes.
Can't hold my pinky down.
7 is yes.
8, no. 9, no. 10, no. 11. Yeah, okay. 12, no. 13. 14, no. 15, no. 16, no. 17?
Yes.
Yes.
19.
18, no.
19?
19? Yes. 20?
No.
No. 21?
No.
22? It's even.
No.
So no. 23?
Well, no, 8. You can do 8.
24? 25? No, so 9. 9 not composite numbers. Okay?
Is there a way to do this using calculators?
This is too much math.
Too much
Is
math.
there a calculation way to use this?
What's that?
A calculator way?
Depends. In this case, not really, no. No, not really. Okay.
Okay.
All right, so you guys go ahead, do number 6 and 7 and 8. 6, 7, 8. No, you can stay at your seat and get it done real quick, Dylan.
Get told.
Okay. That's a great question, Dylan. Can you work with a partner? I don't know if that's true or not. We'll see. I guess you guys got work done yesterday when you were with a partner, didn't you? But I want you to work with this on your own right now. Just go ahead and get it done real quick. Just be quick. 6, 7, 8. No, but the exact opposite would be 25 minus 9.
Did you just call me
If
crazy?
there are 9 prime numbers in 125, there would be 25 minus 9 composite numbers, right? The rest of them are composite, right?
Are you speaking in Forrest Gump accent?
Question? If you were like
Mark Turk.
Okay.
Captain Turkey.
Captain Turk? Turkleton?
Turkman's now about to claim something.
What is the probability?
So if it's spun, it's more likely that the owner will land on the tail side because the head side has a grave on it. But if it is tossed, the side that is down is more likely to be what's right. So like if it's face down and heads is down, tails up,
If you start,
then
okay.
heads is what it's going to land.
Okay.
Wait, so
So if you flip it and it's tails up,
yeah,
you
if
should
tails up
expect
and
it
good
to
heads,
land
it should
head.
land heads.
Interesting.
And if somebody is used to going ahead and only taking out their heads, they should choose the opposite.
Right. Because it goes one more
Wait,
flip.
so there's a whole bunch of math behind it.
Yeah, I
So
heard
let's
it.
say I have heads in my hand. I would heads like this. Heads is down. What would land? What would land? Tails on top. What if someone is like this? You want to choose? And then does this same rule apply here? Or different? If it's like this? Yeah, like so they actually might like if it's like half rounded on your thumb. Yeah. Okay, so that they added another thing to it. So from what they're saying here, if heads is still down,
You want to select a number that is 6
even
or
within the
greater.
edge state, because what it's doing on. So there's like this crazy little math behind it. either
You
touch
said
more odd
six
numbers than
or greater. You said
touch
just
equal odd numbers
what's
and even numbers,
selecting
but you
a
will
number
never
greater than
touch
6.
more
It is
even numbers.
there's 4 numbers greater than 6 out there.
That makes
6 or
sense.
greater. You can
So
count
it's the same with this.
Okay, 3 and
Always,
over.
if you start heads, you're never going to go and get to tails. Remember, you need heads.
Yes.
So you want heads to be one thing or tails face down.
Yeah, no, so if heads is face down, you want to pick heads unless the person's over in your hand. Then you pick
So odd or
I thought tails was the more
That
common.
means
I remember when I was younger, I would always flip a coin. They would almost always land tails.
heads.
But here's the thing.
So yeah,
So yeah.
that's if it's being spun. If you take a coin and you spin it, it's always going to land my tails.
Okay, let's take a look here. Shh. Carson, number 6, what'd you get? What'd you get, sorry? 1/2, yeah, so 5 out of 10 there, or 1/2 if you simplified it. Shh. Okay, 5/10 or 1/2, either way, if you simplified it there, okay? Remember that you're saying 6 or greater, so you count the 6 as a favorable outcome. That's okay. So 6, 7, 8, 9, 10. That's 5 total there out of 10. Okay. Okay. Number 7. A number is chosen at random from 1 to 10. Find the probability of selecting a multiple of 3. Let's go to Matt T. Number 7. What'd you get? 3 over 10. Okay. Multiples of 3, remember, are like 3 times 1, so 3. 3 times 2, 6. 3 times 3, 9. Okay, you could also think of it of numbers that are divisible by 3. Those are also multiples of 3. Okay. Very good, Matt T. Thank you. Let's go to Sky. Sky number 8. What'd you get?
I got 25 out of 50 or 1/2.
25 out of 50 or 1/2. Okay. Yeah, sounds good. Okay. Okay, now, questions on... Shh, Alex. Let's listen up here. Okay, questions on the front. We're all good so far? Okay, turn the page here. Okay, yeah, we'll skip that one. We'll save that for some practice here. Turn the page to frequency tables. Okay, so... Don't be scared here by the tables, okay? These are called two-way frequency tables, and I'll show you what the two-way part is and what the frequency part is. Remember, frequency is just how often something occurs, right? And so we'll read the scenario here, and then we'll see about this table. So the students in a seaside school are to have extra swimming lessons if they cannot swim. Okay, right? You live near the sea. You want to make sure that your students can swim. The table below gives information about the students in grades 7, 8, and 9. Okay, so you've got a table right here, okay, and you can see that in grade 7 there are 120 that can swim and there are 60 that cannot swim, okay? So, is it possible to have a third option here? Like, you can swim, you cannot swim, and is there a third option? No. So in other words, right, either a person can or cannot swim, but there's no like weird person that can like do both, or that there's some other third option kind of thing. This accounts for all students, right? Either you can swim or you cannot swim, okay? And so if we know the number of people that can swim and the number of people that cannot swim, how many people then are in the grade 7 overall? 180, right? 120 plus 60. What's that?
In between 7 and 8, people just took swim classes or something.
Possibly.
Yeah, instead of math, we took swim.
Right, who knows? That's a good question.
The swim, you know the swim sport?
Yes.
I have a friend who does it, and he says it's horrible because like his knees.
It's hard on your knees, really?
Yeah.
For swimming? Interesting. I would feel like it would be, very low impact kind of stuff, but I guess I can see, depending on what kind of thing you
people are
use.
like sweating so hard.
Yeah.
They're trying to win.
Oh yeah.
They're trying.
Yeah, I guess because you're pushing your body so hard, kind of thing. Okay, so same thing is true here, right? Shh. Same thing is true here for grade 8. Either you can swim or you can't swim, so add them up, and we get 179. And then for grade 9, again, add them up, and you get 175. Okay? Now, the grades are similar in size, but of course it makes sense that they're not the same in size because, you know, different grades have different amounts of students in them. Okay? But it should be roughly the same. Okay. Now, another total that we're asked to find is this bottom row right here. Okay? So the total here is going to be the number of people that can swim. So we're going to add up 120 plus 168 plus 172, and we get, yep, 460. Thank you. Okay? And then 60 plus 11 plus 3, I can actually do this one in my head, 74. Okay?
I bet you it's like 580.
Yeah, close. And it's going to be it's going to be 500 something for sure, but 460 plus 74 is 534. Oh, drats. What about the sum of 180, 179, and 175? What's that add up to?
576.
That's going to be 534 again.
Oh.
These three numbers and these two numbers add up to the same total, which makes sense, right? Because this is the total number of people in grade 7, grade 8, and grade 9. So if you add those up, that gives you the total number of people in the school. But then also, if you find the total number of people that can swim and add the total number of people that cannot swim, you should get the same total, right? Because it's also the total number of people in the school. Okay? So, this is a common way of displaying data, at least in math classes. I don't really see them too much outside of math classes, but that's the way we're going to be looking at them here, okay? And so one of the things we need to be able to do is interpret the different numbers here. We're going to use it to maybe come up with probabilities and stuff like that too, okay? So, how many students need swimming lessons?
74.
How do you know that?
Because they can't swim.
74 students cannot swim, so those are the ones that need the lessons, right? So 74 students. Exactly right. Okay. How many students are there in grade 8? Right, well, you need the total number of students in grade 8, not the number that can or cannot, the total, so 179. Okay, you guys get the idea here. Let me start calling on some folks now. All right, let's go to Tyler L. Tyler L, letter D, okay. How many of the 7th grade students cannot swim? 60, right? So grade 7, cannot swim, 60. Great job. Okay. Let's go to someone we haven't heard from yet. Let's go to Sean. Sean, letter E, how many students in grade 7 and 8 can swim?
Grade 7 and 8 can swim.
You can tell me what you would do. You don't have to actually come up with a number. But what would we do here to find the number of students that in 7 and 8 that can swim?
300
You're going a little too high there. What are you adding up? What numbers?
180.
Careful. Can 180 students in grade 7 swim? How many students in grade 7 can swim? 120. How many students in grade 8 can swim?
168.
So how many in grade 7 and grade 8? This plus this. So yeah. 288 students. Okay? Now the next one's pretty straightforward there, but we got this. All right, so let's go to Simon. Simon, how many students are there altogether in grades 7, 8, and 9?
534.
Yeah, we already talked about that one, so that's not bad. Yeah, very good. Okay. Okay, and then it asks us to create a two-way frequency table for the above data. Okay, two-way frequency table for the above data. I don't know if they really gave us space here. I guess that's where that's supposed to go, right there. So let's hold off on the frequency table right now because I don't see the space there for that. So let's hold off on G and H for right now. We'll come back to that. Okay. Let's skip down to letter I there, and we'll maybe come back to that frequency table in just a second. Okay. So let's skip down to letter I. I says, what percentage of 9th grade students can swim? So here's what you got to be careful about. Okay. For this fraction, we're going to make a fraction here, then we'll turn it into a percent. Okay. So what percentage of 9th grade students can swim? So what should our denominator be here? So, right, 175 for the total number of 9th graders, right? Because we're only worried about what percentage of 9th grade students can swim. So we'll put it out of 175, and how many of those 9th graders can swim? How many 9th graders can swim? 172. So we'll do 172 out of 175. Now, do you guys know how to change a fraction? Oh, sorry. Do you guys know how to change a fraction to a percent?
Yes.
How do we do it?
Well, yeah. Okay. So basically, you get that. You get 172 divided by 175. You get the big old number right here. Then you times 100, and you get 98.
So, yeah, top number divided by bottom number, just like you do for your grades, right? So 172 divided by 175, yeah, is 98%. We'll say like 0.9828 there. And so just move the decimal place over 2, and that's equal to then 98.28%. So nearly 100% of the students in grade 9 can swim. Okay, now, the next one says, what percentage of students cannot swim? Now, is this referring to only grade 9 here? No, so what should our denominator be? 534, the total number of students. And how many of the total number of students cannot swim? 74. That's right, out of the 534. So we'll do 74 divided by 534. Yeah, I get 0.1385, which is then 13.85%. Okay, yeah, 14% if you want to round it like that. Yep, exactly right. Okay. Okay. And then finally, letter K here. What percentage of students are 9th graders? Now, what would our denominator be here? What percentage of students?
It would be
534, the total number.
yeah, it'll be 175 over 534.
And then, right, how many grade 9 students, right, are there? There's 175 out of the total of 534 there, which again, divide that up. 32.7%. Okay, so I'll say, yeah, 0.3277, which is then 32.77%.
0.77?
Yeah, or 32 or 33% if you want to say 33% there, just around it, that's fine too. Okay. Okay, now I see what they were asking for the frequency tables too. Okay. Yeah, 32.77% there, here at 13.85%. Okay. This table, the frequency table here, this is how we're going to fill this out. Okay, so I thought this was a frequency table, but I'm not sure. I guess this will be a two-way frequency table here. But I got to clear that up, I guess. Two-way frequency tables. Okay. Anyway, here's how we can do this. So we're going to fill these cells in with percentages, okay, out of our total. So these are all going to be out of the total of 534. Okay. Now that we know that the total in this situation is 534.
You have to put a line over all of these.
Well, because we're going to make fractions, and so I'm just going to fill in all of the... Okay, so we're going to make fractions here for all of these, and maybe I should get a not-so-fat marker to do this. Okay, and what we're going to do is we're going to put above that 534 the number of grade 7 students that can swim. Right, so it's kind of like a probability again, right? We found our total number, 534 was the total, right? And now we're going to put the number of students, grade 7 students that can swim. And how many grade 7 students could swim? 120, right? It's right there. Okay, and then that cannot swim is 60, and then the total is 180 out of 534.
For grade 8, you have 168.
Yep, and the 168, 11, and then
179.
179.
And then for grade 9, you have 172.
172, 3, 175,
and then for the bottom, you got 460.
460, 74,
and I believe the last one would be 534.
534. That's right. Okay.
Wow.
So what this does is it gives us the probabilities of each one of these little cells here, right? It gives us the probabilities for each one of these little cells. So, and I can give the percents here too. So this is like 22%, I'll say.
Let's say 450 or 460 at the bottom.
460.
All right.
Yeah, sorry, my handwriting. Let me zoom in on that some. Maybe that'll help. Okay, so this is the little probabilities for each one of these little cells, right? So we put the number from here over the total, 120 over 534, and we get the little cells probability there. And then 60 divided by 534, 11%, and then 180 divided by 534 is like 33%. Okay, and it makes sense you add them up. 22 and 11 makes the 33. Right, you can do the same thing for all these other ones here. So 168 over 534. I get 31% about, and then 11 over 534. I get about 2%, and so then 179 divided by 534. I get about 33%. Okay, and then 172 divided by 534. 32%. 3 divided by 534. I'll call that 1%, I guess. And then that's going to be 33% as well.
Enough room, so I will have to skip.
Yeah, I'm sorry. That's okay. But you get the idea of what you're supposed to do here. Okay. 86% here. 22, 31, 22. Actually, that would be 85 if I add those up right. Anyway, we'll do it 86. 74 divided by 534. 13, so I'll call that 14%. And so, of course, all of our percents should add up to a total of 100%. Now, mine don't quite, like 33, 33, 33, they're up to 99, not 100, but that's because of rounding errors there. Okay, but they're roughly right. Okay, and you can see then we could have used these to help us answer some of these other questions down here. So, for example, what percentage of 9th grade students can swim? 9th grade students that can swim. Oh, never mind. That's a different thing because it's, yeah, okay. Never mind. Anywho, this can be helpful for some of the questions that we asked. What percentage of students cannot swim? So for overall students that cannot swim, the percentage is 14% there, or 13.85. What percentage of students are 9th graders? Here, 9th graders total, it's 33% of the total there. So, and again, I rounded that. That's actually 32.77. So, different ways to do it here. Okay, so let's look at number 2 here. Okay, now number 2, a principal of a school with 484 students collected information about how many of the students wear glasses. Okay. You'll notice here about this table that there's some numbers are missing. Okay, so go ahead, fill in as much of this table as you can, given the fact that we know that there are 484 students total. So that means right here, 484, right? That's the total number of students. Okay, go ahead and try and fill in as much of this table as you can, given the total number of students there. All right, so give it a try. Fill in as much as you can. Okay, see what you can come up with there. So, for example, if you know 40 boys always wear glasses and 36 girls always wear glasses, what would be the total number of those?
76.
Okay, and then you don't know the number for the boys that wear glasses, but you do know the number of girls, so we can't quite figure that one out. You do have some folks who are never wearing glasses right there. Okay. And please forgive me, I know I am doing binary genders, and I know that can be offensive to some people, but just for the sake of doing math, okay?
You know, in Canada, they wanted to pass a law where it would be illegal if you said, like, it or something. It was a gender thing.
Oh, is that right?
I'm so glad they didn't pass that law.
Yeah.
That's an evil law. Like, it would be illegal
To say
that.
words
Yeah, just say words.
Yeah.
Say words.
Well, I mean, you think about it, that's what it is.
The word it, but you can't, like, say if you talk, if the person is transgender and it's a girl and you go, oh, it over there, and then someone can find that offensive.
Right.
Calling them an it.
Doesn't matter.
So they wanted. So they wanted. So I think that's
what's
just.
your life trying to be the
That's
person you
interesting.
are, and then someone is like, oh, it, and you're like, dude, I'm a girl.
I'm curious about what side was trying to push that, because I could see folks that were on that like they were like, you know, that were like pro. I don't know what I'm going to say, but I can see people that were like that are passionate towards transgender people being like, this is an offensive term to them. But I could also see people that were not compassionate towards them being like, they either need to be decide they're he or she, and that's it, no it. So I can see people doing it both ways. I'm not sure which group would have been wanting that. So anyway,
I know what side just passed that law. The same side that Dylan is on. It's called the Illuminati.
The Illuminati
also
side?
known as the New World Order. No, but they actually do exist.
yeah, do they?
They control, like, you know, in Hollywood,
Yeah.
they make so much
Oh no, I've seen the YouTube videos.
Hollywood
Yes.
is
Watch Shane Dawson.
Shane Dawson's cool.
Oh, is he like the?
No,
the
Shane
conspiracy-
Dawson, he's
He's
dumb.
like the master.
No, he's the best at conspiracy.
No, he's really not.
He's the
He
Dawson.
really is.
No, Dan Calloway.
And
The
then
only
You know
one
what
I
else?
don't agree with
You know Martin
is he
Luther
said
King?
that Titanic never happened.
It didn't.
why did people put that out?
Everybody knows
because
that.
he's
There were
That's,
two shows
why would I
made.
be
There
like,
were
oh,
two
you know,
clones.
Sean's
Actually, there was
You know, there used to be
What?
there used to be a conspiracy theory club at this school, but now it no longer
Wait,
exists.
what happened to it?
You'll have to find out.
Wait, what teacher hosted it?
Mr. Trigger, you'll have to go ask him
Is he
for
dead?
more information. No, he's still alive.
Where is
But the club,
Is he dead?
the club seems dead.
Where is he?
He's in one of the computer labs.
The club? No, but I was gonna say, you know Martin Luther King?
I don't know him, but I've heard of him.
Yeah, you know in one of his speeches he says that like after 300 years the Negro still finds himself lost in his own land. And I've been researching it because I know you know if you ever met somebody who's like black, they have somebody in the other family who tells them that they're Indian.
Yeah.
Yeah. What if all this is what I believe because like there's more. I've been researching it. I even went to the Maryland library.
Okay.
In the Maryland room, like you had to give out your address.
Right.
I put my life on the line to find this out. I found out that most of the so-called African Americans here aren't even African. They were already here. They're just American Indians.
Yeah. So basically,
And he's working for them. It's all his fault. It ties into him.
Alex.
Okay,
He's
fascinating.
right in this room.
Alex, the government shut down the conspiracy club.
No, it's not actual.
Yes, that's right.
The government shut down the conspiracy club.
All right. That was exciting. Let's get back on track here, folks. All right. So anyway, no, it is funny though the conspiracy club doesn't exist anymore. But so we already know that the sum here is 76 because we have the two numbers, right? Here we can't quite come up with that sum, so I have to leave it blank for right now. Here we can do this one, right? And it's going to be 305.
Yeah.
Okay. Thank you. Now let's do these other totals. Well, again, I know this one, but I don't know this one, and I do know that. So I can't find this total here, but I can find this total right here, 36, 55, and 144. 235? Thank you. Now, is that the best we can do? No, because now I know there's 76 total people that wear glasses, and there's 305 total people that never wear glasses. So how can I figure out the people that sometimes wear glasses? Subtract it. Right. 484, take away 305, take away 76. We'll get to that in a second. Because, again, this is the total, and the total will include the 55 in it there. So I get 103 when I subtract there. So 484, take away the 305, take away the 76, leaves me with 103 for that total. And then Hannah Wright. Now that I know the total number of people that sometimes wear glasses, and I have 55 girls that sometimes wear glasses, what can we do to figure out the number of boys that sometimes wear glasses? Subtract again. Shh. So we get 48. And now that I have 48, how can I figure out the total number of boys? Well, it's going to be 40, 48, and 161. Okay, so 249. Okay? And so here we go. All right, we've got our table filled in, and now we can answer all these questions. So why don't you guys go ahead and answer there A through J. Don't worry about F and G for right now. Just go ahead and do A through J, but skip F and G. Okay? So go ahead and try those. A through J, but skip F, G. A through J, skip F and G. We're going to do one more after this one, too. So. Okay, so A through J, skip F, G. Yep. Sure. Sure. Kendall, yeah. You can round those percentages, okay, if you need to. Yeah, don't just do the fractions. Give me the percentages, please. Okay, so answer those questions. Give a couple more minutes here. Paper. I need one more piece of paper. All right, see a few more people working here. One more minute. One more minute. One more minute. Stuck, Mark. What? Are you stuck?
Yeah.
Which one?
Wait, this is how many?
So, what percentage of girls? So, in other words, it's out of the total number of girls, what percentage of them never wear glasses? How many total girls are there?
200.
So that's going to be your denominator.
Can't prove
And then how many girls never wear glasses? So, yeah, so 144 out of 235. And then divide them and get your decimal. Okay. Okay. Let's go to Reagan. Reagan, letter B. Ugh. Let's see if I can get this to work. She was very excited. That's what it is. Very excited to answer. All right, Sean. All right, Sean. All right, here we go. So letter B, Reagan. How many boys sometimes wear glasses? 48 is correct. Good job. Okay, according to this data here. All right, next question. How many students wear glasses some of the time? Let's go to Caden. Caden, how many students wear glasses some of the time? 103. Okay. All right, let's talk about the next one here. The next question. Alex, you want to do it? How many students never wear glasses? 305 is not quite right.
How many students never wear glasses?
Oh my gosh, I'm dumb. I said 76. Yeah, sorry, it is 305. My bad. 305. Okay. Sorry about that. Let's go on to the next one. Are there more boys or girls? Boys.
You're after me. No, you're after me.
No, I said Mark would go next. Sorry, Tyler. Womp womp. But thank you for waiting. Skip F, skip G. Shh. What percentage of girls never wear glasses? Let's go to Dylan. Dylan. Oh, you just got back, so never mind. Okay. Hannah, if you don't mind, please. What percentage of girls never wear glasses?
29.
Ooh. So I put it 144 out of 235 because did you use 235 as your denominator?
I used the
484?
yeah.
Yeah. And you see why you want to use 235 here? Because we're talking about what percentage of girls never wear glasses. And that's okay. So we're just talking about the girls as our total population there. Okay? Okay. And then what percentage of students are boys? Okay, so now we're talking about the denominator 484, and it's about 51.4%, 249 out of 484. And then finally, what percentage of students always wear glasses? What percentage of students always wear glasses? Okay.
I'm guessing 6.
So 76 out of 484, 15.7%.
I was close.
76 out of 484 there. You see the idea? Again, what percentage of students? So your denominator is students, and then how many always wear glasses? 76 of the students always wear glasses. Okay? Questions on any of that? All right, so let's take a look then at one more page here. Onto the back of this one. Okay, now, number 3, we're going to draw our own. Very exciting. Okay? J?
It was 15.7%.
Yeah, 76 out of 484 or 15.7.
Oh, point 7.
Just 0.7, not 77, yeah. Number 3, draw your own frequency table. Sorry, your own two-way table for the given information to answer the question. So, in a class of 32 students, there were 8 girls who played basketball and 5 boys who did not. So, what are our categories going to be here for our two-way table? What are our categories going to be? In the front, right, we had grades, and then we had can swim, cannot swim. On the front, we also had boys and girls, and we had always, sometimes, and never wearing glasses. What are our categories going to be here? We have 8 girls who played basketball, 5 boys who did not. What are our categories going to be? Let's go to Ella first. Go ahead, Ella. Give me 2 categories here. Boys and girls, that's one. And then Tyler C., what's another category we're going to have?
What's it called? Girls who play basketball?
So people who play basketball.
Yeah.
And people who what?
Do not.
Do not play basketball. Right. So let's do this similar to how we did before. We'll say boys, girls. Okay. And we'll put our little total down there too. Okay, and we'll say play basketball. And then we'll say no b-ball. I don't want to keep writing it out there. And then total, of course, over here. I forgot the L in total. That's weird. Okay? So something like that. Now, do you have to put the boys and girls on the left column there? Do you have to put the boys and girls here? No. You could put the boys and girls up here, and then you put the plays basketball and not plays basketball down there. That doesn't really matter. Okay? You can put them whichever way you want. Okay. So now, what are some of the cells that we can fill in here based on the information we're given? Total, 32. Okay? What else can we fill in here? Okay, so we know the number of girls who play basketball. So that's going to be right here. There's the 8. Okay? We also know the number of boys who do not. 5 boys, no basketball. Okay? Is that the best we can do?
No, we can do better than that. Better than that.
We're better than that?
I guess.
I don't know. I think it's the best we can do. I'm trying to think here. Because we don't know the total number of boys, and so we can't say how many do play basketball if 5 don't, right? And we don't know the total number of girls, so we can't say how many don't play basketball if 8 do. We don't know this number, so we can't find this number, and we don't know this number, so we can't find this number. So I think we're kind of stuck for right now. Let's see what letter A says. Letter A says how.
No.
Hmm?
Wait, no.
Yeah, I don't think we can do
I was gonna say, like,
8 girls
we
who.
could get whatever, like, 2 numbers add up to 32, but then we wouldn't know which.
Letter A.
Yeah, so let's see here. So letter A, how many boys played basketball if there were 15 girls in the class? Aha. So now we know there are 15 girls in the class. Yeah. So 15 total girls, which means of the 15 total girls, how many girls do not play basketball? 7, yeah. And that means then how many boys and girls do not play basketball? Right here, 12, yeah. And then we can figure out this number. What's this number got to be right here? Okay. So then I think, yeah, this one will be, well, this one's going to be, no, that one's not going to be 9. So 32 minus 12 gives us 20 here. And so then 8 take away 20. That leaves 12 boys right there. And 12 and 5 makes 17 right there. So I think those are all the numbers right there. Okay. Okay. So let's skip, again, I'm not going to worry about this frequency table, blah. We'll skip C as well. Let's just skip down to D. What percentage of boys played basketball? So what's going to be our denominator here for the percentage of boys that played basketball?
20.
How many boys were there total?
How many boys were there?
Yeah.
There were
17. And then how many of them played basketball? 12, yeah. Like that? Yeah. So 12 out of 17, or as a percentage, okay, about 70.6, we'll say, percent. Okay. What percentage of students played basketball? So that's a total of 32 students. And how many people play basketball, according to our graph here, our table? How many students play basketball? 20 do. So 20 out of 32 total students play basketball. 20 divided by 32. So 62.5%. Okay. And then what percentage of students are girls? So again, out of the 32 students, what percent are girls? Well, it's 15 out of 32, right? So then that percentage is about 46.9%, I'll say. Oops, Okay. Question? You see, but I think so. Right. I think what you're saying. You should say should it be 12 out of 32 is what you're saying. But see, when it says, so for these, like E, what percentage of students played basketball? So that makes me feel like the denominator should be the number of students, right? Because it's like out of the total number of students. Here's the saying, what percentage of boys played basketball? So I feel like it should just be the total number of boys there. you know, just because it doesn't make sense. If we say what percentage of boys played basketball, it should be 12 out of 17, I feel like. But I hear what you're saying there. I'll check on that, and I'll get back to you guys on it. Well, not tomorrow, but Friday, I guess, or whatever kind of thing. Okay, and see. But I feel like it should be this. Could be wrong though. Okay, and I'll check on that. Okay, so what I'd like you guys to do here. Let's see. Yeah, let's do this one. On the very, very back, 5, A, B, C, D, E, F. Okay? That one right there, I would like you guys to do. That'll be your assignment, okay? You have a good, 8 minutes, 9 minutes to get it done. Can you work, or are you just going to copy? You're going to work on it and stuff? Okay, feel free.
What number is this?
On the very, very, very back. Last paper on the back. Number 5 at the bottom there. Okay? You have to fill in the table and then answer B through F as well. Fill in the table, answer B through F.
Yeah, let's do it. Oh, come on, where's my pencil? Dylan, what'd you do with my pencil? Dylan.
Do you still need a pencil, Mark?
Yeah, well, I had a pencil.
Well, here, you can borrow this one right now.
Thank you.
You're welcome. If you happen to find...
You do have my pencil. Give me my pencil back.
Guys, why are we fighting about who's got whose pencils right now, right? Thanks. Bless you.